we talk about parametric equations, parametric equations are often used to describe motion. Well, what do we care about if something is moving? How far does it go? How fast is it going? So we can take a set of parametric equations and use it to determine, right here, here's just your arc length, how far does it travel in a given interval. We have talked about arc length before.
Yes. Well, like the arc length we talked about before, wasn't that like 1 plus f of x squared or whatever radicalized? That's not this though. It is this, isn't it?
I mean, it's just in parametric instead of
1, it's x prime t squared. Tank together.
But dt under.
Okay, so basically we take that radical 1 plus dy dx squared and we rearrange it with parametric, and it's this. So essentially it's the square root of dx dt squared plus dy dt squared. Okay. Yes.
Is the squared on the x prime or the t? Like is it on the quantity for the t?
It's the quantity.
Okay.
Yeah. Is there a question?
So can I write like x prime with like f of x with f of x squared?
Is that what you're wanting to see?
Yeah.
So is like the arc length for this just like basically just literally the length of the
Of the curve.
the
Yeah, like if I have a curve like this, here's A, here's B,
like is it displacement or is it the actual distance?
it's the distance. Like if you walked along that curve from A to B, how far would you walk? Okay, useful knowledge, right? Okay. Without calculus, we can only find like the bird's eye view of the distance, right?
Oh,
What?
I heard that was
Oh.
a question.
Yes, I thought that's what you were trying to bring up, and so I was
It
gonna.
was a question on the math ball that they lost like everything off of that.
How
one
would I
question.
know that?
And
You know random things all the time,
why did they
and
ask
you
that? Like,
insert them very simply.
I'm sorry,
also
that's kind
tend
of
to
a
pop
dumb
up in
question
random
to ask.
Wait,
Okay.
I know
That's not
that.
even math.
What?
Like that's not a math thing.
Okay,
It's just,
for when I'm gone next year on this day, let's keep focused, okay? Arc length from 0 to pi of the square root, sorry, Richard. Caleb, what's dxdt?
the XET.
Yep.
Hold on, I need to copy this.
Is it cosine del 3 cosine 3t?
Okay? And I'll let Caleb do this one. What's dy dt, Caleb?
Wait, this is all we got. Do what? Oh. Negative 3 sine 3t.
Okay, so I have the integral from 0 to pi of 9 cosine squared 3t plus 9 sine squared of 3t. That seems like that should be special.
No, it's weird. I get it. I'm good enough.
What's sine squared plus cosine squared?
1.
So really, that's just radical 9?
Yes.
I'm not there.
I'm not.
Cosine squared of 3t plus sine squared of 3t is 1.
Oh, okay.
Just like cosine squared of 5 billion plus sine squared of 5 billion is 1.
But if it were 2t and 3t.
When you guys said
Correct.
where's the 9 go? The 9, it's under the radical, so it's 3. Oh, you took the 9.
We don't disregard it. It's part of the Pythagorean identity.
But how's like cosine squared of 2 plus sine squared of 2 equal to 1 and 3?
It doesn't matter what the angle is. As long as the angle is consistent, it works. Like I said earlier, cosine squared of 5 billion plus sine squared of 5 billion equals 1. Cosine squared of 15 plus sine squared of 15 equals 1. As long as the angle is consistent, we're good. What's the antiderivative?
3? Probably 3.
Times
Or 3t. Oh, you guys do get it? I was just testing it. Will they all be this easy?
Oh,
Dang it.
But some of them you'll get to use your calculator on.
Those are tricky. I don't want to think about that.
Getting to use your calculator?
No, I didn't understand the homework problems that said use your calculator to find the answer to DT and stuff. I thought like, I didn't use my calculator, and I didn't know how to do that. How to do that? How to graph them. They said use your calculator to find the answer to DT and then dy over DT and dy over dt.
Your calculator can do that.
Okay, well, that's what we're going to mean that.
Use your
I said using a graphic calculator, find blah, blah, blah,
okay.
We'll look at it.
blah. Okay.
What did we really find? Can anybody tell me?
The arc length.
Of what?
The circle.
So really we found a piece of the circumference, which we could have done without calculation. But
Geometric formula.
so if we graphed this, we would have a circle, and if we knew the radius of that circle, then we could find the circumference.
Wait, how's
Because sine squared plus cosine squared.
Oh, that's a circle? I didn't know
The
that was a
unit
circle.
circle?
Did you do the math?
I forgot about that.
Like, we spent like 3
Okay.
years working on this. We did the circle.
Now, what if I wanted to know the speed?
The speed of the circle.
The speed you're going around the circle.
Oh,
Oh.
God.
Oh, wait, no, that's really nice, actually.
Yeah, it actually is.
Whoa.
Oh, yeah.
So nice, actually. That's right, that last one.
Okay, so
Oh, no,
just
it's
hold
just
on.
weird twice.
Hold on. Arc length. Arc length. If I want to know the speed, I'm asking for the rate of change, right?
So arc length over time. The speed.
Okay, so the rate of change of an integral is what?
Just the one
Just
step.
what's inside the integrand is what we call it. So the rate of change, the derivative of an integral cancels out. And we have speed is just what is inside that arc length integral.
Okay.
I didn't like big to work with that.
Oh, but
So S is arc length.
Yes.
Not
I
speed.
don't know why.
No, not speed.
that
That's
should we write it all down or just what
You can just
variable
write
should
it
we
off
use for
that.
So would this give you like instantaneous
What do you ask?
speed?
What variable should we use for speed?
Speed.
Okay.
And then zero
Like,
to
yeah,
right.
is this instantaneous speed or is it like?
Well, it's kind of the derivative, so the derivative is the instantaneous
So
rate.
if I plug in a value for t, I would get the speed at that particular time. So it's not on an interval, it's at one specific t value. What?
Wait, does the
the derivative of this thing that we worked with before, which is our one. Oh, another derivative. I'm sorry. I'm on drugs. Like narcotics. So.
Wait, stop.
That's surgery.
No, I meant that.
Just if we take the derivative, we use acceleration.
Or would we have to do something to get rid of all of the dy?
I'm gonna have to think about that. Like it sounds simple, but
Yeah.
with our institute. What I worry about is that being a radical, and when you take the derivatives, you have undefined values.
Oh.
And to me, that wouldn't make sense for acceleration.
Yeah.
Do you see what I mean?
Well, would you have undefined values? Because it's each of them is squared and then you're adding
And then
them
that's
together.
the negative first. We're 1/2, the negative 1/2 power.
But can you get zero? Because they're both squared. Both
Wait,
things are
he's-
squared and then they're added together.
The derivative of that entire thing. If we take the derivative of that entire thing, we would get something in the denominator because we would have a negative 1/2 power.
Yeah, but it would just be that in the denominator, wouldn't it? Yeah, and since the x prime is squared and the y prime is squared, then it is so that they're always positive and then you're adding them together. But what if they're both equal to 0?
That's what we're. Okay, write this down, please. I need to think about it.
Alright.
Just write this down.
Okay.
Okay.
Yeah, but yeah, there's just a lot of stuff, so I was like wondering.
I know. I need.
Okay, so one speed. Who is it? Just calculated. So that would be. So is x 2t or 2t?
2t. Okay, we are finding the particle speed at 0 and the displacement, or the distance traveled x, and the displacement d. Okay, we're finding the So my t's have curves, but you can make a t with a curve, so then you know the difference between a plus and a t,
You can do it for tangents.
like this. Like a backwards J and then speed at t equals 0.
When
What?
it's squared.
So first of all, our speed is the square root of the xct squared, which is what, Zane? What's the xct? What's dxdt? If this is x, what's dxdt?
Oh, because it's more.
dy dt, Benjamin.
I got 9. No, but that was after the.
Oh,
so it was 3 has t to the 1/2, which is 3 has radical t.
Yes. Okay. So our speed equation is 4 plus 9/4 t. And if we want the speed at 0, then we plug in 0 to get 0.
What?
4, 2, what? 2. For when we find distance and displacement.
I still understand what's going on. I think this is a good sign. I might do well on this next quiz.
Now I want to know the distance traveled, arc length, from 0 to 4. Okay, now what's nice about this is I already know what our integrand looks like, right? We have the integral from 0 to 4 of the square root of 4 plus 9/4 t. Nick, what's our antiderivative?
8/27.
Ooh.
No.
Like, just like, what's the antiderivative? Like, from here to here. Like, this is to the 1/2 power, right?
Yeah.
So if we take the antiderivative, I have a linear in the 1/2 power.
Yeah.
Okay.
So 2/3 times 4 plus 9/4 t. 3/2 times 4 over 9. 8/27.
Oh, that's where you got it. I'm with you. So it's like you use u substitution, where u was 4 plus 9/4 t, and u to the 1/2 became 2/3 u to the 3/2, but then we have that 4/9 to balance out the substitution. So we have 8/27 times 13 to the 3/2 minus 8/27 times
4 to 3/2.
okay, we can do that.
Like, who doesn't just know 13 to 3/2?
Well, it's obviously a mixed number.
Doing a tiebreaker question. Not a mixed number. It's a raffle.
Right.
It's the square root. Excuse me. Yeah, it's the square root of 13 cubed.
That's a dream of mine.
Oh, that's a 2, not an 8. Okay.
I was waiting for this to say something very easy or like said Pythagoras. Like, I was hoping, but
Okay, now, what are you working on? What do I mean by displacement? Okay, so what coordinate are we at when t equals 0? What coordinate are we at when t equals 0? 0, 1. What coordinate are we at when t equals 4? So if I want the displacement, we're taking 8 minus 0 squared plus 9 minus 1 squared. If we plug 4 into 2t, we get 8. If we plug 4 into 1 plus t,
Yeah.
then we have to get 8. Plus 1 is 9. Do you know why it's the distance formula? Mm-hmm. So from one point to another, that's the displacement. Bird's eye distance.
They're very close.
Sorry.
How many more problems? Is it like 1 or 2?
One, another formula, and another. So example, formula, example.
I can make it work.
Write it down.
minimum. Wait, minimum speed.
But that means negative.
Say it one more time because I don't think everyone I think 5 of you all said minimum speed, minimum speed, minimum
Yeah,
speed.
we gotta make sure we're
Well, now I
running.
have to remember how to find the minimum.
Zero or the biggest possible.
Okay, I'm asking you for the minimum speed, right? Can you please set up the speed equation?
I mean, you just.
Set up the speed equation. Go top. Set it up.
Is there a comma there?
Yes.
Is it between the t and t squared?
Yes.
Okay,
Can you wear your glasses next week?
I will.
Thank you.
I just
That's it.
okay.
Anthony, our speed. We have radical. Did I write that? Okay. Nope.
Would it be
What's
better?
the speed?
Would it be better if we close that out now?
Let's just figure out what we're doing.
Wait for.
Okay. We want to minimize the speed. So it's like an optimization problem, right? Okay. Yes. Now, I just taught optimization 45 minutes ago. Okay? Right?
Now you can do it
Collins
again.
and Twins loved it. If we're minimizing a radical, technically, can we just minimize what's under the radical and be fine? So we want to minimize 3t squared minus 4 squared plus 4t squared. And just for fun, I'm going to call this a capital S. Okay? So ds dt is to minimize a radical, we can really just minimize what's underneath the radical. Because if we minimize what's underneath the radical and then you throw the radical on top of it, it's still going to be the minimum. And then it's less algebra for us to do. I don't know about you, but I like less work.
I also like this
Okay, so our derivative. Isabel, help me with this derivative. Thank you. We're minimizing. We need to know where this is. 0. So we kind of have to get this all figured out. So this is like 12t that we need to distribute through, right? So we have 36t cubed minus 24t plus 8t. Cubed. No.
It's 48.
Yes.
Yeah.
Yeah. I did 6 times 4.
Yes. The states too.
Speaking of skates, at UNL, I was gonna walk to the bathroom and out comes this woman on rollerblades, just like in the student union, like coming out of the bathroom, just rollerblading through the building.
That's cool. That's efficiency. Yeah, that's
But how do you
Dangerous.
get stairs?
well for everyone else.
Good. You'd be good.
You don't just slide down the rail.
Just grind on the road. No.
Okay, so this is what we got. What can we factor out?
T. And also maybe 4.
Like 2 twos?
I don't know. I just thought
Okay. So, our critical points are 0 and plus or minus radical 10/3. What did he say? We're finding a minimum? What did you say, though?
Oh wait, no. Yeah, we can plug in a negative as long as the thing under the radicand still comes out to a positive number.
But if t represents time,
Oh, but you can't have negative time. Yeah.
don't care.
oh my god, I don't care about you.
Negative positive? So for sure this is a minimum? Sweet. But if I want the minimum speed, what do we have to do with radical 10/3?
Wait, I have a question.
How do we know it's a minimum?
Real quick, before you leave
Never mind. I'm
this.
sorry. I was like,
Miss Homer,
Yes.
just like before you leave the sign chart, what if it were like positive, negative?
Then it would be a maximum.
Okay, but like, what about 0? Is there any way where that could have been like a
We're beginning at 0.
minimum? Right. So what if 0 is the smallest point in the whole thing? Would that be a minimum? So how
Because
would
it's
you,
an end point.
so how would you know that? Would you have to plug in -1 to like figure out if it, well, you wouldn't have that wouldn't matter. Because you knew it was going up to the other critical point. So then just by process of elimination, you know, 0.
Like if this went plus plus, then you would have a minimum at 0.
Okay, but what if it went plus minus?
Then we would have a maximum speed, and our speed we would have to have a minimum at some point.
Yeah, but if it went plus minus, how would you find the minimum?
We would probably have an interval to where you'd have to check it in.
why are we doing speed
Oh.
again?
I want the minimum speed. I found the time of the minimum speed.
Oh, so can we just plug it back in?
Yep. So that's what I'm doing. I'm plugging it back into speed. Is that okay? Okay. So somebody's calculator can have to help me.
Come on, we're at 34.
We get it. You're in math class. Work ahead.
I think it is great.
That is exactly the baloney I don't want to be hearing.
I actually do know who he is, just not fast enough.
What was the question?
Yeah, what was it?
How do you word that into a question?
Which Greek philosopher was known for his study of right triangles?
You didn't know that fast enough? They must have gotten it like.
Did they answer?
It's like a millisecond.
Okay,
Yeah,
let's
it was-
answer that.
Like
Yo, I was pressing the button when he buzzed in.
It was Aristotle, right?
any questions on this?
He was and
Any questions on this? Okay.
He was and
One
I think you did.
last thing. We do have surface area. This is not an AP topic, but since we talked about surface area in chapter, I don't even remember,
Oh wait,
7,
no.
I thought we might as well bring it up with parametric. Just write it down. It doesn't require any talking.
Does it require knowing it for the test? If it's not an AP subject?
I think what she's saying is we won't do it for the final review, but we'll still be tested over there. Because the final's just the AP test, right? So,
what's the difference between? Oh, it's just like. It's just like it was in the other.
It is.
I like that.
I feel like the freaking arc length one was also just like the one on the other chapter.
Just rearranged
I think they get it now.
to be direct to be the parametric.
I think they know where these are coming from. I think you're gonna do it.
I'm just waiting for you to write this down so you can write the How are you supposed to use a formula if you don't write it down? It's
Radical
writing
level.
for it.
That's what I'm gonna do, but then I know I'm not gonna. You are. No, you're supposed to copy down the top part. No, you're not. Otherwise, why is she waiting so long?
You got 2.
Miss Holman, I hope you're having a
The
wonderful
square of -2/3 is
Thank you, Benjamin, for those brownie points.
Alright, how was that the final
It's 2
question
root 11 over 3.
at a math competition?
It's what?
day. I'm getting the
11 over 3.
Yeah, from the previous one.
That's why I said all
If it matters.
It does matter. Go change your answer.
Is it not right?
No, it's 2 root 11 over 3.
How was that the final question of the state?
Well, it wasn't state.
Okay. It wasn't? I thought that was
I mean,
the
it was.
Effectively.
Which one is what is
Okay.
Let's
You-
count that.
you-
Can we do our example?
So now you said that. I actually disagree.
That one makes a lot.
Yeah, let's do the example.
Go.
I used to think that.
We're ready.
You guys aren't beating yourself up for that competition, are you? I'm sure you did great.
Can we all drop it?
Jokes.
This is supposed to be my class that's not supposed to be stressful.
Wait.
And you might be my most stressful class.
That's fair.
Maths.
It's fine.
I want to know the surface area generated.
The cycle.
I can see what she was going to have this like turn into and together.
Okay, so remember we did a cycloid before, right? It looks like this. Okay, so one arch of the cycloid is all I want. And then when we rotate it around the x-axis, we basically get a ball.
Are you
Right.
ever gonna make us do it around the y-axis? And make it like
No, I don't know, but all
No.
If
I
if
don't
it was
know.
about the y-axis, it would just be x instead of y.
Like, okay.
All right.
50.
I will just tell you to save time that one arc is 0 to 2 pi. Okay, so those are our limits of integration. Now to set up our surface area, we have 2 pi out in front, y of t, and then we have that radical that's appeared in every single thing we've done today, dx dt squared. Plus, that's t. I just saw sine of t. Sorry. 1 minus cosine p, the quantity squared, plus this one is sine.
Oh, that is a 1. Wow, that is.
Oh.
Oh, that's one. Never mind.
Oh, that 1 and t look similar?
They.
At a
Well,
glance.
Yeah, they're both lines with like a thing near the top.
Alright, I'm gonna say it. Every math problem that we did in our homework, it was like exactly the same, just sine and cosine switch.
Yeah, so.
So I just thought it was the same.
But we
Okay.
didn't really look that hard.
Alright, we only have like 3 minutes left.
Wait.
We actually need to go.
Isn't the derivative of 1 minus cosine t not like, wouldn't it be just,
But then we have to square it. It's dy dt squared.
right? But the thing that you put in there was not, wait, let me check
The other one is 1 minus cosine.
Yeah, it's gotta be
Blindly follow
the
them.
derivative, right?
Yeah. The derivative of 1 minus cosine t is cosine t.
But remember,
Right.
your clock isn't
Yeah.
And then squared.
It's great.
Oh, so that first one is the derivative of t minus sine t. Oh.
Calculator problem.
How do you
We just got the answer.
Oh,
Type it in.
Problem.
It's not my fault that she decided to not make the radius 1.
And would you give us the intervals, or how would you?
That like threw me for a loop.
Now, To get the intervals, we could find where dx dt and dy dt were both simultaneously 0, but I think we did that a couple days ago, so we can just 0 to 2 pi was one arc.
Distance is arc length. And speed